Good morning, class. In previous class, we have started that balancing, and hope that portion is clear to you all. Okay, how to balance the reactions, that might be clear. And for regarding this, I have given three questions, of NCERT questions. So hope you have done that also. So I just want to explain, okay, that answer. So let me do that. The question number 1 is why the magnesium ribbon should be cleaned before burning. So in the class only, in that video class only, I have explained that when magnesium is exposed to air, it deposits a magnesium oxide layer on itself. Okay, so which it prevents the burning. So to burn it properly, we should remove this magnesium oxide layer. Okay, so that's why it should be cleaned before burning. Okay, question number 2 is write the balance equation for the following chemical reaction. So question number 2, let me do this first part. Hydrogen plus chlorine is equal to hydrogen chloride. So we know that the symbol of hydrogen is H2 and the symbol of chlorine is Cl2. Okay, so it will form hydrogen chloride, and might be you have learned in the formula in class 9. So this is HCl. If we say to balance it, if I say to balance it, what you will do? This is 2, this is Cl2. In the same way, you have to balance, and this will be 2HCl. Got it? Okay, class. Okay. So balancing you have to do in the stepwise. I'm just writing the answer. Okay. Second question is barium chloride plus aluminium sulfate. Barium chloride formula is BaCl2 plus aluminium sulfate. Aluminium is having 3 charge, yes, and sulfate is having -2. So cross multiplication we can do, and this will be Al2SO4 whole thrice. So when it will be you have to balance, so it will give Ba barium sulfate BaSO4 plus aluminium AlCl3, aluminium chloride. Okay, so for balancing you have to balance with the stepwise, and might be you have done with this only. So I'm just writing the answer, you check it whether it is done in the same way or not. 2 aluminium, so 2 here and 3 here. Okay, 3 here and 3 here it will be. So this is balanced. Okay, so just check the answer. Third one is sodium plus water, sodium Na plus water H2O. Okay, when it is react with each other, it gives sodium hydroxide NaOH along with the H2 gas. This is, so balance it. You are supposed to balance it. So in this case it will be put here 2. Okay, put here 2 and 2 here. It will be balanced. Okay, so just to check this. Okay, question number 3. Question number 3 is write a balanced chemical equation with the state symbol for the following reaction. First is solution of barium chloride. Barium chloride, first one. Barium chloride, it is said solution. Solution will, when it will be solution, when it is dissolved in water. So the state will be not liquid, it will be aqueous. And sodium sulfate in water. Sodium sulfate formula is Na2SO4. Again, this is also in water, so that means aqueous. Got it? Okay. And in water react to give insoluble barium sulfate and it will give sodium chloride. Okay, so this is barium sulfate formula is BaSO4 and sodium chloride is NaCl. Okay, so it is insoluble agar koi bhi substance, then it is called precipitate. Got it? So we have to show in this way. This is the way, because it is PPT. And NaCl, the NaCl will still remain in the solution, so it will call aqueous. Got it? Okay, next is second one is sodium chloride solution in water. Sodium chloride solution in water. This is aqueous because it is in water, as I told you earlier. aqueous reacts with hydrochloric acid solution. It reacts with hydrochloric acid solution. So obviously this will also be aqueous, isn't it? In water to produce sodium chloride solution and water. So this reaction with sodium chloride solutions and a sodium hydroxide it should be. One second. What is this? Sodium hydroxide is there. That's why no problem. Sodium hydroxide solution is there. When it reacts with HCl, it will give you sodium chloride solution and water. So water will be liquid state. We will not write aqueous because it is not dissolved in water. The state is there. So that's why we will write H2O as a liquid. Got it? Okay, so this was very whatever the balancing we have done, that was a very simple balancing. We have to do some different balancing also. So let's do some questions with this higher level. Okay, so suppose that I am giving you MnO2 plus HCl, and it will give you MnCl2 plus Cl2 plus water. How to balance this? Okay, how you will balance. So for this, again you have to check elements. You have to write Mn, oxygen, hydrogen and chlorine, isn't it? Okay, one second, my pen is not working properly. Okay, LHS and RHS. How many Mn in this side? LHS 1. This side 1. How many oxygen this side? 2. How many oxygen this side? 1. How many hydrogen this side? 1. And how many hydrogen this side? 2. How many chlorine this side? 1. And how many chlorine this side? It will be 2 plus 2, 4. So don't write 4. You just write 2 plus 2. Like the first compound, the chlorine present in the first compound and plus and chlorine atom present in the second compound. Got it? So it will be easy to balance. How, which will be balanced now, which will be multiplied, that will be quite clear for you. Let's see. Okay, so let's start with this. Mn is balanced, oxygen is not balanced. So let's start with this oxygen we can do. Okay, so if we multiply by 2 in this, so what we will write? Multiplying by 2 in oxygen with of it what? Water. Oxygen of water in RHS. Got it? So write it, what it will be. This is Mn, we have not changed anything. MnO2 plus HCl will be like this. Change into MnCl2 plus Cl2 plus 2H2O. Okay, the same thing we have to repeat again. This is Mn, this is O, this is H and this is Cl. Okay, LHS, RHS. Wait. So this is RHS. Okay. You have to write that number. How many magnesium over here? Magnesium is 1 on this side. How many magnesium on this side? 1. Okay. Then oxygen is 2 and oxygen is also here 2. Got it? Hydrogen is 1 on this side. Hydrogen is 4 on this side, isn't it? Chlorine is 1 on this side and chlorine is 2 plus 2, 4 is this side. So what you have to do? Just balance the hydrogen, okay? Multiply with the 4 in hydrogen. So you will get like 4 hydrogen will be there on this side, left side. Yes. So write down, just multiply by 4 in HCl on the left hand side. Okay. So we have to write, I'm writing it here. Okay. Multiplying by 4 in HCl, in H of HCl in LHS side, isn't it? So if you multiply, it will be MnO2 plus 4HCl, then it will be MnCl2. We have not changed anything in this side, so let it be like this only. Now again check how many magnesium? 1. This side also 1. How many oxygen? 2. 2. How many chlorine? 4. 2 plus 2, 4. And how many hydrogen? 4. 4. So the reaction is balanced. Got it? So in this way you can balance it. So I'm giving again 2-3 reactions you have to balance, like homework. You can write PbNO3 when it is heated, it gives PbO plus NO2 plus O2. Similarly, on this side oxygen is 1 plus 2 plus 2 you have to write. Got it? Then you do the multiplication, otherwise it will be problem. Okay. Next is Fe2SO4 whole thrice if we heat. So this will give you FeSO4 plus SO2 plus O2. Got it? FeSO4 plus SO2. 1 second. Don't write this. Okay. So this is, and some questions of your back exercise I am giving. Just wait. I will tell you what to do. So in the back exercise you have to do the question number 6, question number 6, 7, 6 and 7. Got it? Okay. And 5 also. Do the 5 also. Okay. Okay. So this is the balancing, and hope if you will practice it, it will be clear. So just hoping that you are practicing it. Okay. Practice a lot. As much as you will practice, you will be expert in this. Got it? Okay. So now we are going to start the new topic, that is types of reaction. Types of chemical equation. Okay. What are the types? There are varieties of there are many types for this. So just categorize every type. We are going to categorize the reaction in each type. So first type we are going to do, this is A, combination reaction. Combination reaction says that if two or more elements or compound combine together to form a new compound, then it is called combination reaction. Just for format I am writing, if A is a compound or element, B is a compound or element, and they together they are combining and it is forming AB only, single product. Got it? So then it will be considered as combination reaction. Okay. So just example, write down here, 2 or more reactants combine with each other to form a new single substance or compound. Okay. Best example you have done since starting you are doing. This is Mg plus O2. When it is heated, it gives MgO. Got it? To balance like this. Okay. So this is the combination reaction. Next is C plus O2. This will give CO2. Next is H2 plus O2 will give H2O. Got it? Okay. So this is combination reaction. In this combination reaction, one thing I just want to explain about the combustion reaction. Okay, so there is a combustion reaction and combination reaction. ध्यान से just be attentive for this. N2 plus 3H2, it will give you 2NH3. Okay, so combination says that it forms a new substance, new single substance. This is called combination. And combustion says that if any substance is heated in presence of oxygen, it is known as combustion reaction. Got it? And then you can write in that note, combustion reaction. Any substance, if it is heated in presence of oxygen, there are two words, be careful, heated and presence of oxygen. Any substance, if it is heated in presence of oxygen, the reaction is known as combustion reaction. Okay, so I just want to ask, out of these three, and whenever this combustion reaction will be there, it produces tremendous amount of heat and light. Okay, so this is also the thing to learn. Whenever combustion reaction will be there, first it is heated in presence of oxygen, and along with the product there will be heat and light also. Okay, so if we write here heat plus light, even all these reactions give heat and light. Got it? Heat here, this also heat gives. Okay, so I just want to ask, out of this and one more equation, let me write, like CH4 plus O2, when it is heated, it will give you CO2 plus water, heat and light. Okay, so this is equation 1, equation 2, equation 3, equation 4 and equation 5. I just want to ask, out of these 5, which are the combination reaction? Combination says that only the two or more reactant combine and form a new substance. That's it. It doesn't mean that is burning with oxygen or it is producing heat and light or not. It doesn't mean. It simply says if the two atoms combine, two elements combine, two compound combine and form a new compound, it will be considered as combination reaction. So there is the tell me which are the combination reaction. Combination reaction, if I am writing combination, so tell me which are the equation which will be combination reaction. Two elements are combining to form a new compound. So yes, this is equation 1 hai. Equation 2, two different elements forming a new element. Equation 2 is also. Equation 3, two atoms forming a new substance. Yes, equation 3 is also combination. 4, yes, two elements combining with a new atom. 4 is also a combination reaction. 5th is a combination reaction. These two are combining, but they are not single product. It is giving two products. So 5th is not the combination reaction. Got it? Okay. Combination, single product should be formed. Okay. Okay, now next if I'm saying combustion reaction. Combustion reaction. So combustion reaction, what it says? It should be heated in presence of oxygen and heat and light should be provided. So okay. So it is heated in presence of oxygen. So equation 1 is combustion. Yes. Equation 2 is combustion. Yes. Oxygen burning, heat and light. Equation 3 is combustion. Yes. This is also in presence of oxygen it is burning. Okay. Equation 3, is it a combustion? Combustion hai, no oxygen is there. So equation 4 is not a combustion reaction. What about equation 5? Yes, oxygen is there, burning is there, heat and light is there. So combustion. Got it? So I think it is clear, combination and combustion reaction. These are two different things. One is combination, another is combustion reaction. So you have to learn it. Okay. Now there is the activity 1.4 in this. It says that take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown. Do you feel any change in temperature? Okay. In this combination reaction only, I just want to explain 2-3 things of exothermic and endothermic reaction. So activity 1.4, if we do activity 1.4. So it says that calcium quicklime is CaO, okay, and when in beaker and slowly add water to this. So this will give you CaOH whole twice, okay. And what will happen? This beaker will be heated, okay. So we can say it releases heat. The beaker will be heated. So we can say it releases heat. So tell me, is it a combination? Is it a combination? Yes, because two are combining to form a single. Is it a combustion? No. Why? Because it is not burning in presence of oxygen. And third equation, I am just going to tell you, exothermic reaction. Exothermic reaction where heat is released. Okay, I will write exothermic reaction. What is this exothermic reaction? Such reaction in which heat is evolved during the chemical reaction. During the chemical reaction is known as exothermic reaction. Got it? So it is liberating exothermic reaction. So yes, it is an exothermic reaction. Got it? Is it clear? One point in note you are supposed to write, note, all the combustion reaction will be exothermic. Why? Because combustion definition is there. It releases tremendous amount of heat and light. So all the combustion reaction will be exothermic reaction. Got it? Okay. So this is the point you have to learn. Another fourth definition is there in this combustion combination part only I am explaining. Okay. Endothermic reaction. Endothermic reaction. Such reaction in which heat is what? Absorbed or required, okay, is known as endothermic reaction. Got it? So wherever heat is required, heat is needed, it will be considered as endothermic reaction. And as a result, what will happen? Like in this exothermic reaction, as a result, the container becomes hot. Yes? But in endothermic reaction, as a result, the container will be cold. Okay? Got it? Okay, so another that you have to go through with this yellow box. In this it is written, a solution of slag lime produced by the reaction 1.13 slag lime CaCO3. Okay, so that the yellow box, let me read first and then I will explain what it is. Okay, so a solution of slag lime produced by reaction of 1.13 is used for whitewashing walls. Okay, whitewashing you might be seen. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Okay, calcium carbonate is formed after 2 or 3 days. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny lineage to the wall. Bilkul shines a little bit, shine is there. It is interesting to note that chemical formula of marble is also CaCO3. So here in class 9th you have learned that formula. So it says that how this calcium carbonate will form. This comes under note only, okay. So you have to make calcium carbonate. How it will form? To form calcium carbonate, actually what happens when this calcium oxide, quicklime, reacts with carbon dioxide, it forms calcium carbonate. So tell me, is it a combination reaction? Yes, sure, combination reaction. Is it a combustion reaction? No, because oxygen is not there. Got it? Is it an exothermic reaction? Exothermic? When it when calcium carbonate forms, it needs heat. Okay, so it is not exothermic, it is actually endothermic reaction. Endothermic, it needs heat. Got it? When this calcium carbonate actually what it is, it says that how it forms. Another way is also there. Calcium OH CaOH whole twice. Okay, this is slag lime. Slag lime is used for slag lime. It is used for what? Whitewashing. So when this in this calcium oxide, if you dissolve this into water, you will get this calcium hydroxide. So calcium hydroxide is slag lime and it is used for whitewashing. Got it? So when we do this whitewashing, after 2 or 3 days, this reacts actually carbon dioxide. It starts reacting on that time only when we apply this coating, okay? But it gives the result after 2 or 3 days. When calcium hydroxide reacts with the carbon dioxide, this carbon dioxide is present in atmosphere. Got it? So what happens? This forms CaCO3 along with this water. So water, where it does go? Actually it evaporates. Okay, it evaporates, and this, it forms a layer of this CaCO3, which is a shiny layer. Got it? Got it? And in this it is said that there is a formula, marble. You must seen many marble. So marble formula is CaCO3 and it has also shine. Got it? Because of this. So this is the combination reaction in which we have done 3 other type of reaction, which is combustion, exothermic and endothermic reaction. Now the second type of reaction. Okay class, one thing before starting the second type, I just want to tell you that some reactions, natural reaction like respiration, we breathe. So there is a difference between breathing and respiration. You might be studied in bio. Okay, so respiration is also an exothermic reaction. Like whatever we eat, carbohydrate, proteins and all that, when it burns in presence of oxygen, it takes oxygen, and this oxygen comes here from what we breathe. Okay, so it reacts with this, and it splits into, it forms a smaller compound, smaller part, and then get digested. So in these time, like in this duration, it provides heat, it provides energy, and that gives the energy to work. Okay, so it is also an exothermic reaction. Respiration is also an exothermic reaction. And another reaction is also there in that in your book. It is given a few reactions you have to learn. That decomposition of vegetable matter, like compost, when we like in a digger we put this vegetable matter and it will convert into manure after some time. So that decomposition of the organic vegetable matter into the compost is also an exothermic reaction. It is also called exothermic exothermic reaction. Got it? So this is the thing, exothermic reaction example, and under the first category only. Now the second reaction we are going to start, and the second reaction is decomposition reaction. Okay, decomposition reaction. Decomposition reaction is just opposite of combination, reverse of combination, reverse of combination. Okay, what is this? Suppose that in the combination, what was that? The two substances combined together to form a new substance, isn't it? In the decomposition, what will happen? The one substance will decompose into two or more substance. Got it? Definition, let me write. One compound in presence of one compound will split into two or more substances, which you can say compounds. Okay, in presence of heat, light, or electricity. Okay, so there will be some like we have to provide some energy due to which this undergo decomposition. If you write the format, it was AB, and then it will split into A plus B. Got it? Like this. Two new substances will form, or two or more than two. Okay? So example, let me do that example. Right now I have given this example. PbNO3. When PbNO3 is heated, it gives PbO plus NO2 plus O2. Here is a single reactant, and on heating in the product, as a result, it gives three different compounds. Got it? Similarly, if we like CaCO3, another example, CaCO3, when it is heated, it gives CaO plus CO2. Okay, इन तीनों से मिलके इसका बनना, that will be considered as combination. इन दोनों से मिलके इसको बनना, that will be combination. But इससे दो substance का बनना, that will be considered as decomposition. Similarly, like this. Got it? So whenever the single compound is undergoing decomposition, dissociates into two or more compound. Got it? Another example we can take, like FeSO4. When it is heated, it gives Fe2O3 plus SO2 plus SO3. So again, this is a single compound. On heating, it undergoes. Okay. Another example, that can be the example. And now, on the basis of heat, light, or electricity, decomposition reaction is classified under three category. This is A, decomposition, in presence of heat. In presence of heat. Got it? If any single compound undergoes decomposition and that is in presence of heat, is known as thermal decomposition. Thermal decomposition. Got it? Thermal decomposition. Example, all these three are the thermal composition only. CaCO3, whenever we put a sign like this triangle sign, it shows the heating sign, okay? It gives CaO and CO2. To be more informative, what we can write, CaCO3 is solid. When it is heated, it forms CaO solid and CO2 gas. Got it? So this is decomposition reaction, thermal decomposition reaction, or you can write any one of this. Okay? B, decomposition in presence of light. Okay, is known as photolytic decomposition. Photolytic decomposition. Okay, or this is also known as photolysis, photolytic decomposition or photolysis. Got it? Example, we can say like AgCl. When it is exposed to sunlight, H nu is sunlight, okay? It gives Ag plus Cl2. AgCl is a solid, Ag solid and Cl2 gas it will. Got it? So this is decomposition reaction in presence of light, photolytic decomposition or photolysis. Similarly, we can do AgBr also. AgBr solid in presence of HNu. HNu means light, okay? This gives Ag solid and Br2 gas. Okay? So this is decomposition in presence of light. And C is decomposition ठीक है, in presence of electricity. In presence of electricity is known as electrolytic decomposition. Okay, let's do some example with this electrolytic decomposition. Like whenever water, or we can say NaCl also it goes. So just write down another example, like we can say in presence of H2O. Okay, when it undergoes decomposition in presence of electricity, okay, it will give you H2 plus half O2 in order to balance it, or you can write it as a 2H2O electricity 2H2 plus O2. Got it? So this is called electrolytic decomposition. So there are many reactions you have to go through with this NCERT also. There are the equations given over there, you have to learn. Okay, so this is the decomposition reaction. In this some activity is there, so let me this activity. In this activity 1.4, we have done activity 1.5. Take about 2 grams of ferrous sulfate crystal in a dry boiling tube. Note the color of the ferrous sulfate crystal. Heat the boiling tube. Cover the flame of the burner or spirit lamp as shown in the figure 1.4. Observe the color of the crystal after heating. Listen, this is activity 1.5. It says that FeSO4. If we take FeSO4, actually this FeSO4 doesn't exist as FeSO4. It exists as FeSO4.7H2O, and that is green in color. Okay, if you see FeSO4 as a green in color, it means it consists of 7H2O molecules. It's understood. Got it? If FeSO4 is green in color, it must have 7H2O in this. When we heat this, first of all, what will happen? This 7H2O molecule will evaporate, FeSO4, and this will give 7H2O, which will be evaporated. So now, since all the water molecules get evaporated, so this color will be white. Got it? If we continues further heating, this FeSO4 will break into compounds, that is Fe2O3 plus SO2 plus SO3. Got it? And this Fe2O3 will be reddish brown in color. Reddish brown. Okay. So if I will ask you what happens when ferrous sulfate crystals are heated, what are the color change? You are supposed to write the equation like this and then the color change. Green color will convert into white first and white finally turn into reddish brown. Got it? So this is activity 1.5. Done. Now activity 1.6 is also there. So let me clear this. Activity 1.6. Is it visible? Yes. Activity 1.6. What it is? It says that take about 2 grams of lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame as shown in figure 1.5. What do you observe? Okay, so listen, PbNO3 hold twice. It says that what happens when it is heated. If we heat this, it gives PbO, NO2 and O2. That you have to learn. Equation what it will form, you have to learn. And one thing I just want to explain. Okay, first let me complete this and then I will do. Okay, so this will, what is the color change? Says that you will observe. So PbO, that color will be like yellowish. Okay, and this NO2 as a gas, it will go out brown fumes. Got it? And oxygen has no color obviously. So what you will say? This reaction when lead nitrate is heated. This is lead nitrate. When lead nitrate is heated, what happens? It dissociates into lead oxide plus nitrogen oxide plus oxygen. And what will be the observation? It will give you yellow residue niche, bottom, and then NO2 brown fumes will come out. So there are the two observations. You will say something yellowish precipitate will settle down at the bottom and brown fumes will be observed. Okay, so this is the observation. Activity 1.6. Okay, now we have done activity 1.6. Okay. So this is the equation. Done. Activity 1.7 is also there, so I think it's related with this, so I have to explain this. Activity 1.7. Activity 1.7 says that take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrode in this rubber. This is actually, okay, I will tell you. electrodes in these rubber stoppers as shown in this figure. Connect these electrodes to a 5-volt battery. Fill the mug with the water such that electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe that formation of bubbles at both the electrodes. These bubbles displaces water in the test tube. Is the volume of the gas collected the same in the both of the test tube? Once the test tube are filled with the respective gases, remove them carefully. Test these gases one by one, bringing a burning candle close to mouth of the test tube. Caution. Okay, so listen. This is activity 1.7 is actually electrolysis. 1.7. It explains electrolysis. In this electrolysis, what it says, we have to make a cell. In this, there is a cell like this, okay, and we will put 2 electrodes over there. In the book, it is like joined from the bottom. So let me do in the same way. These are like joint, and it is attached with the battery. Okay, so this is like, okay. In this, the one which is attached with the bigger line is called positive terminal and is known as anode. This is anode. Okay, and one which is attached with the negative short line, this will be negative and will be considered as cathode. Okay, so put it into water. You have to put the water with few drops of H2SO4. H2SO4 will give the dissociation, will give the medium to dissociate it easily. Okay, so what will happen after some time, when we will connect it, after some time we'll see the air bubbles on this. Okay, so you have to learn that at cathode, hydrogen bubbles will be there, and at anode, oxygen bubbles will be there. Okay, that you have to learn. Now, how can you test what the gases are? Okay, so collect these gases in 2 test tubes. Okay, and a burning matchstick bring on the mouth of the test tube. The test tube which is having hydrogen bubble will give you pop sound. Okay, and the test tube which is having oxygen bubble, there will be no sound. Got it? So this is the test for the hydrogen gas. Test tube containing hydrogen gas will give you pop sound, while the oxygen gas won't give any pop sound. Got it? Question is asked in this, the volume of the 2 gases, will it be same when it gives like this? Okay, so if hydrogen bubble is in test tube 1 and anode bubble is in oxygen gas will be in test tube 2. So tell me whose volume will be more. H2 has double volume than the oxygen, isn't it? In this you can see, or if you balance it, then also you will see this is 2H2 and O2, isn't it? So hydrogen is double than the oxygen. So that means volume of tube 1 will be more than volume of tube 2. So we can say that volume of tube 1 is doubled than volume of tube 2. Got it? Okay. And the test of hydrogen, what you will write? Test of hydrogen. Test of hydrogen gas. Bring a burning matchstick on the mouth of the mouth of the test tube. Okay, test tube. The test tube having hydrogen gas will give pop sound. Got it? So this is the test for hydrogen gas. So activity 1.7, I think it is clear. Okay, now in this page only activity 1.8 is there. So that also we have to go. Activity 1.8. It says that take about 2 grams of silver chloride in a china dish. What is the color? Place the china dish in sunlight for some time. Observe the color of the silver chloride and in some time. So listen, AgCl, it is placed in the like any dish, china dish, and we leave it for some time. So this color is, what will be the color? It is white in color. Got it? Color is white. When we leave for some time, it takes due to the sunlight. Okay, due to the sunlight, it is split into Ag plus Cl2. So Ag will be silver in color, or you can write even gray also, but silver is the most appropriate one. Okay, so this is the observation. What you will say, that the white color of silver will convert, the silver chloride will convert into silver or gray color of silver because it undergoes photolytic decomposition. Got it? Photolytic decomposition. Hope it is clear, and you people are supposed to write it in your class notebook side by side. First go through with this video, and whatever the problem you face, you just ask in a separate way, and you have to note it down in your fair notebook. Got it? Yeah. Okay, so next is that there are next type that we will do in next class. Okay, so class, thank you for today. Thank you.